Very good morning to one and all. So today what we are going to study the pending parts of your 8086 microprocessor. That is your last topic in uh, your module 3. Okay. So so we have seen some features of 8086 in the last class. So what are the features we have seen there? The most important thing is it is a 16-bit microprocessor and it is a 20 address lines are there. I hope you all can hear me. Is there any difficulty? Please let me know. Am I audible right? Okay. Okay. Thank you, guys. Okay. So we have seen some main features of your 16-bit 8086 microprocessor. The main thing is it is a 16-bit microprocessor. While compared to your 85, it is a 16-bit and you have 20 address lines and 16 data lines are there. Okay. And its memory is about 1 MB storage. Then it has some powerful instruction set. So the instruction set as well as the addressing mode that we are going to see today. What is the instruction set? What is the addressing mode? That is the main topic we are going to discuss today. Then we have seen about some two modes of operation. One is maximum mode and another one is minimum mode. So maximum mode A means your system can be accessing access multiple or it can work with multiple processors. That is maximum mode. So the system is having multiple processors, which is known as maximum mode. And if your system is having only single processor, okay, so one individual processor is doing all the work, it is known as the minimum mode of operation. Then we have some features. Features also the same thing. As uh, actually, this one is a 16-bit processor, so everything is in it is in a 16-bit, right? First, the 16-bit ALU is there, then 16-bit registers are there, then internal data bus, 16-bit external data bus. All the things are 16-bit. And one of the most important thing you have seen here, the most important advantage of 8086 is it has an instruction queue which is capable of storing 6 instruction bytes at a time. Okay, and that is the most important thing. And one more thing is it can be execute the program as well as it can retrieve the instruction from the memory. Okay, so both the things can be happened at the same time. That is known as parallel pipeline. Okay, that is what is the pipeline is known as. Okay, so that is also one of the most important features of the 8086 processor. Then what we have seen that is same pipelining, nothing but test stage as well as execute stage. So at the same time, it can test the data and also it can execute the data. But in the 8085, what is happening? Once it is fetch the data, then it is execute. Once it is over, then only it is again fetch the data. Okay, so it will take a more uh, time. Okay, it will take more time compared to 8086. So all both the operation is carried out at the same time. 8086 is working with the less time. Okay, it is only nanosecond like that. It is not in the case of minutes or seconds. It is a nano microseconds like that. Then another one is most important thing in 8086 is it is a 256 vectored interrupts are there. So interrupts also we have seen there are two types of software interrupts is there, hardware interrupt is there. So what is software, what is hardware? Okay, so all those things also we have seen in the previous class. Then we have seen the comparison. As far as you might be knowing, what are the comparisons? In case of size, 85 is an 8-bit, 86 is a 16-bit. Address bus, 85 is a 16-bit, 86 is a 20-bit address. Memory, this is 64 KB, 86 it can access up to 1 MB of memory. Then instruction that is 86 is having instruction queue, but 85 is doesn't have an instruction queue. Then pipelining is support only for 86. It doesn't have anything in the 85 case. Input output, it is a 8 address lines, right? 8 data lines, right? So 2 raised to 8 input output you can access. So 2 raised to 8 is nothing but 256. But in the case of 8086, that is 2 raised to 60 because the data bus is a 16-bit data bus. So it can access 65,536 input output. Then cost is definitely, so all the features are there in 86, so definitely cost will be higher in the 8086. Then what we have seen about the architecture of 8086. So what is architecture? Architecture actually it is divided into two. First one is BIU, second one is EU. BIU is nothing but bus interface unit. EU is nothing but your execution unit. So all the EU is acts as the brain of your system, right? It is giving commands to the bus interface unit. But EU is not having any direct communication with any memory or peripheral devices. It doesn't have any communication, direct communication. So whatever it is required, it will instruct your bus interface unit to either it needs to receive data or it has to read the data, write the data, fetch the data. So all those operations will be carried out by BIO only with the instruction came from your um, execution unit. Okay, this is what is execution unit as well as bus interface unit. Here, what is there? Arithmetic logic flags also we have seen different flags. Then these registers also we have seen. So that also we will see. Execution and BO unit. So all those things. Conditional flags. While coming to the flags, there are two types. One is conditional flag. Second one is control flag. What is conditional flag? So that is working based on the operation of your. That is based on the operation of your. What to say, based at ALU. Okay, so what is the output it is received in the ALU? You have the conditional flag. So conditional flags are of 6 types: carry and auxiliary carry, then parity, zero, sign, overflow. Okay, what do you mean by carry? If D7 bit is having an overflow, then carry flag will be set. If D3 bit is having an overflow, auxiliary carry flag will be set. Then what is parity? If odd number of ones, if one is having odd even number, the total ones in the system in the answer is having even number, then parity flag will be set. And if it is odd number of ones, the parity flag will be reset. Zero flag, if the output of the result is zero, then zero flag will be set. Sign flag, if it is a negative answer, sign flag will be set. Overflow flag means if the answer is exceed the memory limit. Okay. If the answer is exceeds the memory limit, then overflow flag will be set. This is what is the conditional flag. Then what are the control flags? Control flags are three: trap, interrupt, and the direction flag. So that also you have seen there. What is trap flag? Trap flag is if it is enabled, what does it mean? It will execute the program step by step. Okay, it won't execute the program at the same time. It will execute the program step by step. That is trap flag. Interrupt flag means it is allow or prohibit to the interrupt. Okay, interruption of the program. That is interrupt flag. Then direction flag is for a string operation. It is used for string operation. So string bytes are accessed from higher memory address to the lower memory address or vice versa. That is nothing but your direction flag. Then you have seen about the general purpose registers. So how many general purpose registers are there? 8 will be there: AH, AL, BH, BL, CH, CL, BH, and DL. Okay. So where AH and AL is combined as you can together, this is 8 bit. AH is an 8 bit, AL is an 8 bit. So together you can call it as a 16-bit register. So AH and AL you can combine together as AX, BH and BL combined together as BX, CH and CL combined together as CX, DH and DL combined together as DX. Okay. These are the general purpose registers. So AX is used for arithmetic operations. So that is an accumulator register. BX is nothing but base register. CX is counter register. Okay, it is used as counter. DX is used for input output operation. So these are the operations of your general purpose registers. Then what we have seen, stack pointer register, that you know what is stack pointer register. that you have seen in the 8085 also. The next one is bus interface unit. Based on the instructions received from the execution unit, your bus interface unit is going to work. Then next one is segment register. Segment register are four, that is CS, DS, SS, and ES. Okay. What is CS? CS is nothing but code segment. DS is the data segment. SS is task segment. ES is extra segment. So everything is 16-bit address. The next one is instruction pointer. So these are the main points of your architecture. Okay. So you have to draw the diagram as well as you have to draw the you have to give the explanation also, right? So that is what is um, about the architecture. So you have to explain each and every point. Next, what we have seen about the 8086 pin diagram. Okay, this is what is the pin diagram. So there are totally 20 address lines are there. So they are A0 to A14 here, then A15, A19 to A90. Okay, A15 to A90. So these are the address lines. So AD0 to AD15, it will be act as both as your address line as well as data line. And the upper units will be worked as only the address line. A 16, 17, 18, 19 will be only for the address transfer. Okay. So this is the 8086 pin diagram. So we have seen the different we have seen about the different pins, all the 40 pins we have seen. And next one is, what is that? Then we have seen about the interrupts, right? So there are interrupts means it is creating a temporary halt during the program execution. That is what is the interrupt is doing. Then what is ISR? ISR is a short program to instruct the microprocessor on how to handle the interruption. So this is very, very important. The interrupt service routing, you have to study that, you have to study the definition, you will definitely get a question. Okay, so what is interrupted service routing? That is nothing but it's a short program to instruct the microprocessor on how to handle the interrupt. This is what is the interrupt, right? Then we have seen there are two types of interrupt. First one is hardware and second one is software interrupt. What is hardware interrupt? There are two hardware interrupts in the pin. They are NMI and INTR. NMI is a non-maskable. You cannot once it is accessed through NMI, it has to work. Whatever operation is doing, it has to work the same thing. That is NMI. Then INTR is a maskable interrupt. So it is not necessary to if you want, you can work it out. Otherwise, you wait there. Okay, I'll try like that. It will tell. That is what is INTR is doing, right? So these are the two hardware interrupts. First one is NMI, non-maskable interrupt, and second one is INTR. That is uh, non. It is a maskable interrupt. INTR is a maskable interrupt. So highest priority is given to the NMI only, right? That is what we have seen, NMI as well as INTR. Next one is software interrupt. So software interrupt, we have seen that there are 256 interrupt types are under this group. Okay, there are 256. 256 type 0, 1, 2, 3, 4. It has some specified uh, values, right? It has some specified purpose. Then 5 to 31, it is reserved for a higher, if you are upgrading. Okay, if you are upgrading your microprocessor, that time type 5 to 31 will be used. Then next thing is 32 to type 255. That is available for both hardware as well as the software interrupt. Right. This is what we have seen about the interrupt. Right. Do you have any doubt regarding this till this point? Do you have any doubt? Shall we proceed further? Is that okay? No response? Nobody is there? B section ಯಾರು இல்லையா? C section? Nobody is responding? No response from B and C section. Jeevika, Kritika, no response. Okay, okay, we'll proceed further. Okay. Now we are going to study about the instruction sets of 8086 microprocessor. Okay. What are the different types of instruction? What are the categories of instructions are there in 8086 microprocessor? So it is categorized as into 8. Okay. So there are 8 instruction sets are there in 8086 microprocessor. First one is data transfer instruction. Second one is arithmetic instruction. Third point is bit manipulation instruction. Fourth point is string instruction. Fifth one is program execution transfer instruction or branch and loop instruction. You can call it as a branch and loop instructions also. Then next one is processor control instruction, iteration control instructions, and interrupt instructions. So these are the 8 instruction sets available in 8086 microprocessor. Okay, data transfer, arithmetic instruction, bit manipulation, string instruction, program execution transfer, process control, iteration control, and interrupt instruction. So both the instructions are having different um, okay all the instructions are different only, so you cannot use the same instructions what is there in 8085. Okay, so all the instruction set is different for 8085 as well as 8086. So we will see one by one. So what do you mean by data transfer instruction? So data transfer instructions, excuse me, data transfer instructions which is used to transfer the data from the source operand to the destination operand. Okay, what do you mean by operand? Can anyone tell what is operand? What is operand? What do you mean by operand? What is operand? Quantity on which an operation is to be done. Anything else? Constant or variable? Now response from A and B. Arunita, 105. Tell me what you mean by operand. Malavika, 219. What do you mean by operand? A variable on which operations can be done. Okay, so we will see what is operand, right? Okay. The instructions which are used to transfer the data from source operand to the destination operand, right? So you have some data, right? You have some data. You need to transfer the data. It can be anything. It can be register, uh, data in the register or the direct data, whatever it may be. You can transfer from one location to the another location. For that purpose, you are using the data transfer instruction. Uh, so here these are the commands which use to transfer the data. Instruction to transfer a word. Okay. So move, M-O-V, move is a one command. Move used to copy the byte or word from the provided source to the provided destination. Byte or word means because it can be either 16-bit or 8-bit. Okay. Byte means 8-bit. Word is a 16-bit. Okay, so we are using, it can be either byte or word, or you can transfer 16-bit data or 8-bit data. That's why we are calling it as a transfer of word. Suppose if you are using the command move a comma b, let it be some example. Okay, a you assume as an accumulator, b is your dx register. Okay, so which one is your source operand and which one is your destination operand? Move A comma B means what you have to do? You are transferring the data from B to A, B register to A register. Okay, you are transferring the data from B register to A register. That is what is destination and uh, source. Okay, source means move A comma B. After the comma, that is the source operand. Okay, before the comma, that is the destination operand. Okay, first you write the destination, then you are writing the source, right? That is what is destination and the source operand. So that is what is the move command. Then C push. Used to put a word at the top of the stack. From accumulator to top of the stack, you are using push command. Then pop command is you are using from top of the stack to provided location. It can be anywhere. Mostly you consider it for your accumulator. You are considering your accumulator. You are fetching the data from the one location to the stack pointer, stack location to the accumulator or any other provider location, whatever it is. So that is what is pop command. So you have to be remember this command, push as well as pop command. Push means you are pushing the data from accumulator or provider locations to the stack pointer, top of the stack pointer. Okay. Pop means you are fetching the data. You are fetching the data from the top of the stack to the accumulator or whatever it may be. Right. That is the provided location is given. Next one is push A. You have to put all the registers into the stack. So whatever registers you are using, all the data you are transferring to the stack. That is push A command. Then pop A command is it is retrieving the data from stack to all the corresponding registers. That is pop command. Then exchange, XCHG. Okay, it is used to transfer, exchange the data. Suppose I am having a 12, I have a data of 0x, okay, and some other person is having a data of 1x, whatever. Okay, it can be anything. So what we are doing, exchange means the data which I hold is transferred to the second person, and the second person's data is transferred to me. That is what is exchange. XCHG. You can call it as exchange itself. XCHG. Okay, that is what is exchange command. Then XLAT, it is used to translate a byte in AL using a table in the memory. This is not that much using because you are using only the simple programs. You are not using that much in the XLAT command. Okay, it is used to translate a byte in AL. AL is your accumulator, right? AL. So translate a byte in AL using a table in the memory. That is what is XLAT. Next one is instruction for input and output port transfer. This is data word transfer. Okay, your data transfer, word transfer. Second one is it is used for input and output port transfer. Input and output port transfer. So what are the commands there? In, out, LEA, LDS, LES, and etc. Okay. In command is read a byte from the provided port to the accumulator. In, okay, it is reading. Out means whatever be there in your accumulator, it is you are writing it in the input output port. You are sending out. Okay. In means you are receiving the data. Out means you are sending the data. That is what is in and out port transfer. Next one is instructions to transfer the address. These are the instructions which is used to transfer the address. Here data through input output port. Here this is you are using instruction to transfer the address. That is LEA, LDS, LES. What is LEA? Used to load the address of operand into the provided register. Uh, if you are giving a command with LEA means it is loading the address. It is not loading the data. It is loading the address only. Okay, in the provided register. Next one is LDS. It is used to load the DS register and the other provider registers from the memory. It is LDS means it is used for DS register only. LES means it is used for ES register only. Okay. DS means data segment, ES means extra segment. Okay. DS is data segment register, ES is extra segment register. LEA is load the address operand into the provided register. It can be used for any register, LEA. Okay, the LDS means it is used only for data DS register. Then LES is used only for the ES register. Okay, this is what is the register instructions to transfer the address. Now we are going to see the instruction to transfer the flag registers. So what are the flag registers? You have totally 6 flags are there, right? So all the flags, so 8 flags are there. So we will see one by one. LAHF means used to load AH with the low byte of the flag register. Okay, this is an 8-bit address line. So, it is a 16-bit. The flag register is also, it is a 16-bit. So LAHF means whatever be there in the first 8 bits, it will be loaded in AH register. That is LAHF. Then SAHF means store AH register to low byte of the uh, flag register. Okay. AH register, whatever values there in the AH register, that will be stored in the flag register, lower byte of the flag register. That means D0 to D7. Then D8 to D15 is the upper or a higher byte of the flag register. So it will be stored in the D0 to D7. That is SAH. Then next one is push F. So this is used to store whatever content is there in the flag register to the stack. Pop means whatever be there in the stack to the flag register. So you just see this is what is the symbol used for here with the push. Push F means the flag register. Pop up means pop a flag. Okay, pop and push is having the same meaning everywhere. Wherever you are using, it will be having the same meaning. Push and pop. So push means data uh, to be stored in the stack, top of the stack. Pop means you are retrieving the data from top of the stack to the your normal registers. Okay, that is push and pop. So here you are using F means that is push flag registers. Here pop flag register. Okay, so this is what is the instruction to transfer the flag register. So do you have any doubt regarding this? You might be copy this one 8086 instruction set. You copy the instructions which is given here. Then we will move further. Once you have completed, please let me know. Then we'll move further. So what about others? Did you finish or not? Okay, so we are moving to the next set of instruction, that is arithmetic instruction. Okay, so arithmetic instruction, what is the use of arithmetic instruction? It is used to perform arithmetic operations. Okay, it is used to perform the arithmetic operations such as addition, subtraction, multiplication, and division. So the advantage of 8086 is multiplication and division is it's easy in the case of 8086 compared to the 8085. 8085 it is a bit complicated, but in the case of 8086, mm, multiplication and divisions are a bit easy, right? So that is the advantage of 8086 while comparing to 8085 in the case of arithmetic instruction. So the instruction which is used for addition is ADD, ADC, INC, AAA, DAA. Okay. ADD is add the provided by two. It can be 8-bit, 8-bit to 8-bit or 16-bit to 16-bit. So you are categorizing the two, 8-bit addition as well as 16-bit addition. In the case of add to data, right? That is add command. Then ADC is means add with the carry. In this case, it is not considering the carry command, right? So, but in the case of ADC, add with the carry. ADC is add with the carry. Then INC means increment by one. Increment the byte or word provided by one. Okay. Suppose if it was 1 1 0, 1 0 means 0 0 1 0, then 0 0 0. That is 1 0. 1 0 8. We are using it as in 108, right? So that is uh, it is incremented by 1. So it will be added by 1. That is increment by 1. A. So these are the commands you might be getting the question paper. So what is AAA? What is DAA? Differentiate between AAA and the DAA. So these type of four commands you can expect. So you read in between the lines, then only you can write all those things. AAA means adjust ASCII code. Okay, ASCII code. What is ASCII code? ASCII code means then numbers and letters will be there in the ASCII code, right? So ASCII code after addition. You have to adjust the ASCII code after addition. ASCII after addition. That is AAA. ASCII after addition. Next DAA is decimal after addition or subtraction. DAA means decimal after addition. AAA means ASCII after addition. So that is what is AAA and DAA. So these are the instructions which is performing addition command. Next we are going to see subtraction command. So same as add here, here you are using sub. Then add with carry, you are using subtract with borrow. Then here it is increment, here it is decrement. Then instead of AAA, you are using ASCII after subtraction. DAS means decimal after subtraction. Okay. So these are the commands. Some additional to our NPG and CMP. Here what is sub means you have to subtract the data. It can be either byte or in the word format, either 8-bit or 16-bit. That is sub. Then SBB means subtraction with the borrow. Subtraction with borrow. Like in the case of ADC, it is addition with carry. Similar way here, subtraction with borrow. DEC means decrement by 1. Okay, decrement by 1. INC means increment by 1. Okay. Next one is NPG. NPG is used to negate each bit of the provided byte and add 1 by 2, 1 by 2's complement. So this is not much used. So you won't get question also in this portion. Okay. So this is not that much used command NPG. Then CMB is compare. CMB means compare only. Compare to provided byte or word. So then you have to tell whether it is greater than, less than, or equal to. That is the compare command. AAS means ASCII after subtraction. Okay, ASCII after subtraction is AAS. DAS is used to decimal after subtraction, and just decimal after subtraction. That is what is DAS command. Next, we are going to see the instruction which is used for multiplication. Multiplication is MUL means multiplication. So that is byte by, this is unsigned byte. Okay, this is not signed one. Okay, this is unsigned byte by byte or word by word. That is mul command. Then imul command is multiply signed byte. Okay, it is a signed word. Sorry, signed data. Here it is an unsigned word, unsigned data. That is mul and imul. AAM means ask, adjust ASCII after multiplication. That is AAM. Adjust ASCII after multiplication. So these are the three commands we are using for the multiplication operation. Now we are going to see the division operation. DIV means unsigned division. IDIV means signed division. Okay, signed or unsigned division. Okay. Next one is AAD means adjust ASCII after division. Next one is CBW. So used to fill the upper byte of the word with the copies of sign bit of the lower byte. That is CBW. Then CWD is to fill the upper word of a double word. Double word means 16 into 16. So totally, sorry, 16 plus 16. So that is a 32 bit. Okay, this is a 32-bit data. Double word with the sign bit of the lower word. So that is CWD and CBW. So these are the instructions you are using in the arithmetic operation. So there are four types: addition operation, subtraction, multiplication, and division. Okay. So these four categories of instructions uh, are there in the arithmetic operation, right? Is there any doubt in this one, arithmetic operation? Shall we proceed? Shall we proceed? Okay. Next one is bit manipulation instruction. So what is bit manipulation instruction? So bit manipulation instruction means it is used to perform operations where data bits are involved. Okay. So it can be logical operations, shift operations like that. So we will see one by one what is the bit manipulation instruction. So first one is to perform the logical operations. Logical operations means what is not, and, or, XOR, and test. These are the logical operations are performing in the uh, instructions. Okay, we perform the instructions for logical operations. Not means invert the data. If we suppose if you have one, then you are inverting one as zero. That is not operation. Then what is and? And means the same command it will be generating. What is if it is 1 into 1 only, you are getting as output as 1. Okay, if it is 1 into 0, 0 into 0, 0, 0 into 1, all these three cases you are getting uh, output as 0 only. Okay, so that is what is AND operation is doing. So it can be either byte type or 8-bit or 16-bit. It can be also 8-bit or 16-bit. Next one is OR operation. OR operation also 8-bit or a 16-bit command. XOR operation means exclusively OR operation. Okay. So both the source operand as well as the destination operand they must be having, okay, all both the cases it must be having what to say, same size. Okay, it must be same size, byte to byte. So one is 8-bit and the second command also should be 8-bit. And if it is one is 16-bit, the second command is also must be 16-bit. Okay, that is the only thing you need to check there. So they are not AND, OR, and XOR. And the test means add operands to update flags without affecting the operands. That is the test command. So here also it is only bit. If you want to check or set or reset a particular flag, you are using the command test. So these are the instructions which is used to perform the logical operation. Next one is shift operation. Shift, actually you have to see the shift or shift and rotate, because each word is you have to study thoroughly. Okay, then only you can write the shift and rotate operation. So what is SHL bar SAL? Uh, Shift bits of the word towards left and put zeros in LSB. That is shift command. Shift SHL means shift left. Okay, shift left. It is moving left. If you are giving SHL to AX, suppose you are just giving a command like that. So what is happening? One bit is, so all the bits are moving left. All the bits are moving left. So what is happening at the LSB? LSB, it is not, the last D7 is not coming back to D0. That is what is the problem. Okay. So D0 is moving to D1. D1 is moving to D2. D2 is moving to D3. The similar way, D6 is moving to D7. Okay. And D7 is moving out. It is not coming back to, it is not at all coming back to the D0 bit. Okay. So what is happening in the D0 bit? D0 bit will be 0. So it is put the D0 bit as 0. That is the SHL and SAL command. Similar way, SHR command. So all the bits are moving in the right side. Okay. D7 is moving to D6, D6 is moving to D5, D5 is moving to D4. Like that it is moving. And the last D7 is not having any command, any byte or any bit. So what is what will you do? You will put the 0 in the MSB bit. That is SHR command. Now, SIR command is used to shift or byte towards the right and copy the old MSB into the new MSB. So, SIR command means it is moving right only. Okay, it is moving right only. So, what is happening in the MSB? MSB D7 is moving to D6, but D7 also will carry the same value. What was in the previous case in the D7? Suppose D7 is having 0. First, suppose you are giving an instruction SAR, D7 0 is moving to D6. So D6 also 0, D7 also 0. That is SAR command. But in the case of SHL bar SAL, in both these commands, there is always you are keeping 0 in the LSB. And SHR, MSB is 0, but SAR, you are keeping the old MSB in the SAR command. So this is the shift operation. I hope you understand. If you have any doubt in this one, shift operation, is that clear? Shift operation is clear? And tell me, is that clear or not? No response? Okay, I got some response from A section. A and B as well. C section. Okay, let me proceed further. So this is what is shift operation, right? Next one is rotate operation. Rotate operation, ROL, ROR, RCR, RCL. These are the rotate operation. So rotate operation means used to rotate bits of byte word towards the left. Okay. ROL means rotate left. ROL means rotate left. NSB to LSB and to carry flag. So whatever be there in the MSB, it is moving to the carry flag. Also, MSB is moving to the LSB. So if you are having D0 here, sorry, D0 here, D1 here, D2, D3, D4, D5, D6, D7. Okay, it will be like that only. So what is happening? It is moving towards left. So D0 to D1, D1 to D2, D2 to D3, D3 to D4, D4 to D5, D5 to D6, D6 to D7. So what is there in the D7? D7 is moving back to D0. Okay, here it is D7, so D7 is moving back to D0. That is rotate left, and also this MSB bit will be sent to the carry flag, whether it is there in carry or not, right? So that is also sent to carry flag. Then rotate right. Rotate right means uh, here it is D7 and here it is your D0. Rotate right, D7 to D6, D6 to D5, D5 to D4, D4 to D3, D3 to D2, D2 to D1, D1 to D0, right? Then D0 to MSB. Okay, LSB to MSB, rotate right. So LSB, D0 is moving to the D7 bit. And also what is happening, it will be in the carry flag. It will send to the carry flag also. That is rotate left as well as rotate right. Now next one is RCR. RCR, what is happening in the RCR? LSB, it is rotate right only. Okay, rotate right only. In ROR, LSB is moving to MSB. Also, LSB is sent to carry flag. So, what is there in RCR? LSB is moved to carry flag, and what is there in the carry flag? It is moved to MSB. You cannot tell LSB is moved to MSB. LSB is moved to the carry flag, and from carry flag it can be either 0 or 1. Okay, so that bit is moved to the MSB. That is RCR command. Next one is RCL. RCL is ulta of this one. So MSB is moving to carry flag, then carry flag to LSB. That is RCL command. Rotate left through carry flag. Here, rotate right through carry flag. So I hope you understand what is the difference between shift and the rotate operation. So this is very, very, very important. You must study. Okay, you must study all these instructions, and only you can write it in the examination. Suppose they are asking for RCR, RCL, ROR. Okay, it can be anything. So you must study this. What is this command? Now, I hope you may copy down this command, mainly shift operation command. Then we will move to the next topic. Once you complete this one, please let me know. You finished? Okay. There are so many absentees in C section. What happened? Only Saturday is responding from C section. What happened to others? In A section, Arunita and Gayatri. B section, only Jivika. Okay, we will proceed further. So these are the bit manipulation instructions. Okay, these are the bit manipulation instructions. So that is used for logical operation, then shift operation and rotate operation. Right. So you have to be familiarized with these instructions. Okay. So what is the difference between each cases? ROL and RCL, ROR and RCR. What is the difference between all these cases? So you have to be study what is the instruction. Now we are moving to the string instructions. String instruction is one of the advantage in 8086 compared to your 85. So string instruction is a group of byte or words and their memory is always allocated in a sequential order. Okay, it must be in a sequential order. That is string instruction. So the string instructions, these are the string instructions. REP means repeat the given instruction till counter is equal to 0. You are putting a counter value. Okay, let it be CX is equal to 10. CX is equal to 10. It is then each and every time it is a decrement by 1. Okay, CX, then you are giving decrement CX. So what does it mean? Decremented, what is there in the CX register, it will be decrement by 1. Right. So every time it will be repeat. The same operation will be a repeat whenever the CX command is equal to 0. What CX register is equal to 0, then only it will be exit from that loop. It is a loop only, right? So that is repeat instruction. Then repeat A, then repeat is Z. First one is it is used for repeat the given instruction until CX is equal to 0 or 0 flag instead of is equal to 1. Sorry, here it is not is equal to 0. CX is not is equal to 0. You have to repeat the same thing. Here it is ulta. Whenever it comes to 0, you can exit from the current instruction. That is repeat E or repeat is Z. It means that your zero flag is set as 1. When your zero flag is set as 1, your the result CX is equal to 0. Then the 0 or either this one is equal to 0 or zero flag is equal to 1. You have to repeat the instruction. That is REP and REP E or Z. Then REP NE or REP NZ. Used to repeat the instruction until this is not 0, okay, or this is equal to not 0 and 0 flag is equal to 0. So that is REP NE and REP NZ. Then move S, move SB and move SW. That is move, it will be S comes means, move means normal move operation. If S comes means it is a string operation. Okay, this is a string operation. It can be byte, one byte of data, byte of instructions, byte of string, one string to another, byte or word. Okay, it can be, it is a continuous thing, right? It is a series of commands. Okay, it is series of data are there. So it is taking either byte or word. MB means it is a byte, move a bit byte, byte means 8 bit, or move W means word. Okay, it is a word. It is a 16 bit. That is move as P, move as W. Then COM means compare. Okay, COM means compare byte or word. S means it is a string operation. So compare byte or word. Compare two byte or word. That is the COM command is used for. Then INSB, INSW. So IN means input string from the input output port to provide at the memory location. That means your processor is going to read the command, that is in command. In means whatever be there in your input output peripheral devices, you are reading. The processor is reading. So you are taking the data. Okay. And out means it is a string data, but you are sending it to output devices. Out means you are sending. You are writing. Writing means it is a sending. You are giving the you are giving it communication with some other device. Okay, you are sending to some other person. So that is out command. Then that is in and out. Uh, yes, yes varumbod it becomes string operation. Okay, so that is the only difference between the normal in and out command, the move, compare command, all those. Then SCA means scan a string and compare its byte with a byte in AL or string word with a word in AX. That is SEA. Then LOD means load or store the string byte into AL or string word into AX. Byte means it is an 8-bit only, so you are using AL. If it is a 16-bit, you are using AX. Normally, byte means you are using the lower part. Okay, AX means your AH is there, AL is there, but usually you have to use the AL only. Similarly, if you are using BX, lower byte means always used in the BL register. Okay, so that you have to be remember. So these are the string operations: REP, REPE, REPNE, move command, compare, in command, out command, then scan and compare. Load means store the string byte into AL or AX. That is AL or AX. It cannot be AH or AX. It is always AL or AX. So that is the only thing you have to be remember. Okay. So these are the commands which we are going to use for the string instruction. I hope you understand. Is that okay? Shall we proceed? You can write for if you want, you can copy down. You copy down and please let me know. Once you have done, let me know. Did you finish? A and B section, did you finish? Okay, okay. Now, what is next? 1 second. Now it's readable, right? Okay. Next one is program execution transfer instruction, that is branch and loop instructions. So these instructions are used to transfer or branch the instruction during an execution. Okay. So it includes, these are the some instructions that is used for loop of branching. Okay. It can move to from one location to the another location of that particular program, that is looping or branching. So these instructions uh, during an execution without any condition. So it will be repeatedly doing. Okay, that is what is these instructions. So they are called RET means return, then jump. Uh, so these are the instructions without any condition. These are the instructions without any condition. They are call, return, and jump. Call means you are calling some other subroutine, subprogram. Okay, you are calling some other program. That is call function. Return means once the subroutine is over, you are returning back to the main program. Return. Okay, that is a return command. Then jump means you are giving jump to once this instruction is executed, you have to jump to some other location, right? So that is what is jump instruction. Okay. So these are the instructions which doesn't have any condition. Okay. Whenever you are giving, it will be executed. Call means you are calling some subroutine program. Once your program is executing, main program is executing, you have to call some subroutine. Subprograms, you have to call that subprogram. Once the subprogram is over, you're giving return command. The return command means it will be go back to the main program. Right? That is return command. Jump is you are jumping from one location to the another location. That is jump command. Okay. These are the instructions without any condition. Next one is these are the instructions with some conditions. Okay, if and only if this condition is accepted, or if and only if this condition is there, then only you can move. Okay, that is what is the instruction with the condition. So JA bar JND. What is JA? Gem of above or not below or equal. Instruction satisfied. Satisfied. If the instruction jump above or jump below. Okay, jump not below. Jump above and not jump not below. That is based on the equal instruction satisfied. Next one is jump AE, JEE, and JNB. Jump is above and not below instruction satisfies. Okay, that is jump above or not below. Then jump BE, JNE. Jump is below or equal and not above instruction satisfied. JC means jump on carry. Okay, JC means jump on carry. So jump if carry flag is equal to 1. Okay, if there is a carry in the accumulator, so the same will be reflected in the carry flag. So that is JC, jump on carry. JE and JZ. So jump on equal or jump on 0. That is either if the data is equal or jump on 0. If otherwise 0 flag has to be 1. If the answer is 0 or jump on equal. If the answers are same or if the different if the answer is 0, then jump on equal or jump on 0. Okay, 0 flag. Then JG bar JNL. So jump on greater than not less than or equal. Not less than, jump on greater or not less than or equal. So all these commands you might be knowing. Then JGE, jump on greater than or equal, and jump not less than. Okay, not less than. So that is this command. Then JL is jump is lesser, JNGE is jump not greater than or equal. Right. Then JLE and JNG, that is jump less than or equal or gem not greater than. So these are the commands. Gem JNC, gem gem bond no carry. So mainly used commands are JC, JE bar, JZ and JNC. Gem bond carry and gem bond not carry, non-carry. Then gem bond equal and gem bond zero. These are the commands mainly used. These are the commands we are not that much used in the our program, because we are writing only basic programs. We are not using these commands. We are mainly using JC, jump on carry, jump on non carry, then jump on equal and jump on equal. These are the commands we are using. So these are the instructions which it has some condition, and these are the instructions it doesn't have any condition. Okay, instruction without conditions are call, return, and jump, and with the instruction without with the conditions are all these instructions. Jump on carry, jump on non-carry, jump on equal, jump on zero, jump on greater than, jump on less than. Okay, all these things are the instructions which is having some conditions. If the conditions satisfies, then only it will be jump from one location to the another location. Then here also some more are there. JNE, that is jump on not equal, or jump on not zero. JNO is jump on non overflow. JNP is jump on parity, or jump on non parity, or jump on parity. JNS is jump on sign, not sign. Okay, sign flag. Jump on JO means jump on overflow. JP means jump on parity or parity even. Okay, parity and parity even. JS is jump on sign flag. So it is always based on your sign flag. Most of them is based on your sign flag only. Okay, so based on that, N means is not. Okay, it will be zero. Or JNO means overflow. It is representing the overflow flag, right? JNO means jump non-overflow. So overflow flag is zero, it will be jump. If it is one, it will not jump. If you want to jump on overflow flag is equal to 1, you are using jump on overflow, JO. Okay, that is what it is used. If you want, you can copy down. You mainly copy down these instructions: JNE, JNS, JNO, JNP. These instructions you might be copy down, because these are mainly used ones. So we will proceed the remaining instruction set in the afternoon class, and the afternoon class we will go with the instruction set as well as addressing modes, right? So these two topics we will cover in the afternoon class. Okay. I hope you and I'll stop recording.